With CIS multi-cluster support, organizations can expose applications running across multiple Kubernetes clusters through a single BIG-IP virtual server, centralizing traffic management, simplifying multi-cluster delivery, and ensuring consistent security. In this video, we'll give an overview of how F5 and Nutanix work together to make multi-cluster application delivery, centralized traffic management, and consistent security not only possible, but effortless for today's modern containerized applications. For this demo, we're working with a high availability F5 BIG-IP pair. We have very minimal configuration on the BIG-IP at this time. We've created only a single partition named nkp CIS demo, which CIS will use to manage all Kubernetes objects. We're using the Nutanix Kubernetes Platform, NKP, to manage our Kubernetes clusters. We use Nutanix as our NKP provider, which uses Cilium as the CNI. For now, we'll focus on the first 3 clusters that we've deployed across 2 Nutanix AOS clusters. NKP CIS Demo 0 and NKP CIS Demo 1 are on the same AOS cluster. NKP CIS Demo 2 is on a different AOS cluster. The 2 sample applications, Hello and Cafe, are already up and running on all 3 Kubernetes clusters. To make the demo easier to follow, each cluster's terminal section is color-coded. White is for NKP CIS Demo 0, our cluster 0. Green is for NKP CIS Demo 1, our cluster 1. And orange is for NKP CIS Demo 2, our cluster 2. Cluster 0 is where CIS will be installed. We've enabled static routing for Cilium on CIS, allowing static routes to be created automatically on the BIG-IP. Here you can see CIS multi-cluster has been deployed successfully, and a virtual server resource has also been created for both Hello and Cafe. We can see that CIS has pushed the configuration to the BIG-IP. Application services for both Hello and Cafe have been provisioned, and static routes have been dynamically created for all nodes across Kubernetes Cluster 0, Cluster 1, and Cluster 2. First, let's take a look at the Hello. A virtual server has been created along with its pool and pool members. We can reach the application, and we can see it's load balanced across all 3 Kubernetes clusters, Cluster 0, Cluster 1, and Cluster 2 as expected. Next, we'll scale up the pods on each cluster before moving on to the Cafe application. As you can see here, CIS keeps the BIG-IP up to date in real time as changes happen. Cafe has 2 services, coffee and tea, and both are configured correctly through CIS on the BIG-IP. Here's an example from Cluster 0, where the pool members are fully synchronized for both services. We can reach cafe tea and coffee as well. Everything is reachable and responding as expected. Now imagine we deploy Hello on a new cluster, NKP CIS Demo 3, our cluster 3. We simply update the CIS config map and the virtual server resources to include this new cluster. Once applied, the Big IP updates accordingly with the new configuration. Let's scale up the pod on this new cluster, and we can see the changes reflected immediately. As we can see here, Hello is now load balanced across all 4 clusters: Cluster 0, Cluster 1, Cluster 2, and the newly added Cluster 3. CIS can seamlessly attach BigIP security policies to your applications, ensuring they stay secure and protected. Here, we've created a WAF policy called Policy Demo, but at the moment, it isn't attached to any virtual servers. Neither the Cafe nor Hello virtual server has a security policy applied yet. CIS manages security through custom resources. We reference the WAF policy in a policy custom resource, then attach it to our virtual server custom resource. We can now see that policy demo is attached to both virtual servers, Hello and Cafe. Both Hello and Cafe remain fully reachable and load balanced across the clusters. But now they are protected. As you can see here, when we attempt to attack the applications, the requests are immediately blocked. If we check the log on the Big IP, we can find more information of the requests, including the detected attack type, and in this example is a cross-site scripting attempt, which is successfully mitigated by the attached WAF policy. CIS also supports high availability using primary and secondary roles. As you see here, the secondary CIS does not push any configuration to the Big IP. This is expected behavior. In XA mode, only the primary CIS pushes configuration to the Big IP, while the secondary CIS continuously health checks the primary and only takes over, pushing configuration to Big IP if a failure is detected. Together, F5 and Nutanix simplify multi-cluster operations, delivering unified application delivery, consistent security, and effortless scalability for your modern containerized applications. For more information, please reach out to your F5 representatives. Thanks for watching.